right, hello folks. We're trying a new method for recording my videos. Let's wish us some luck on this. All right, so for today, we are learning Module 6, Day 4, which is the volumes of pyramids and cones. Whereas you learned the prisms and cylinders last time, the pyramids and cones have similar base structure, but they meet at a point at the top instead of having another base of the same size. So the formula for volume, kind of funny, but you still use the same idea as you did for the prisms and the cylinders, but then you divide by 3. Fun fact, the volume of a pyramid and prism that have the same dimensions, you can pour whatever's in that pyramid into that prism 3 times and it will equal its volume. So that's why we divide by 3. For today's lesson, you will need a calculator for sure and something to write with. And the formula page might be handy so that you can be looking at that as you practice. So here we go. The Egyptian pyramids, oh, these things are huge, aren't they? And they're just beautiful. And they're just amazing when you think about how they were and when they were built. So the formula is base area times height divided by 3. Since the Egyptian pyramid has a square base, we multiply 756 times itself. So that's base area. And then the height is 481. And then we divide all of that by 3. Now, I'm going to tell you something right now. If you're the type that doesn't like to do fractions, which is what this looks like, you're not going to get as precise answers. So please be sure to multiply everything out and then in the very last step, divide by 3. Or you can divide by 3 if it goes into something evenly. Do not make this a multiplier of 0.3 because that is far less accurate than dividing by 3. So I'm now going to use my handy dandy calculator, and 756 times 756 times 481, and then I'm going to divide that all by 3, and it's a ginormous number, 916,362. And I have to put commas in or else I can't tell what I'm looking at. So there, 91,636,272 cubic feet. That's a lot of sand and dirt inside, or, mummies maybe. Okay, I want to point out that these are square pyramids. We're not going to do this one, but 1, 2, 3, 4, 5, looks like 3, 4. It's got 6 sides. This would be a hexagonal pyramid. You could have triangular pyramids. You can have rectangular pyramids. You could have octagonal pyramids. Whatever the shape is on the bottom is the name, and it just comes to a peak at the top to make it a pyramid. Guess what this one's called? It is called rectangular because the base has different dimensions, a length and a width, not like the square. The formula, however, is pretty much the same. Multiply 8 times 4 times height, and then divide all of that by 3 when you're done. Or, fun fact, this will go in nicely. So now you're really just multiplying 32 times 3. And when I do that, I get 96. And these were not named, so I'll just say units cubed. That's the pyramid. I'm not going to go into much more detail because it's really a prism divided by 3. The cone is very similar to the cylinder divided by 3. In the formula, base area times height divided by 3, you are always going to put in pi r squared because the base is always circular. The worst part, of course, for these problems is you have to have possibility of 2 types of answers. So for the first ones, I will leave pi. And for the second one, I'll give the decimal answer rounded to the nearest tenth. Okay, so the formula is, I'm going to write it right here, just remember, base area times height divided by 3, but we're going to insert this in for base area. So for this, pi times radius squared, it's got a diameter of 2, so the radius is 1. So 1 times 1, the height of this cone is 5. And then I'm going to divide that by 3. So the pi is just going to sit there, and when I multiply everything here, I get 5, and there's a 3 in the bottom, so I leave it. 5 over 3 pi. And these are inches cubed or cubic inches. The decimal of that, basically take that 5, multiply times 3.14, and divide by 3. So you're just replacing, right? 5 times 3.14 divided by 3. 5.2. And this was inches cubed. So an ice cream cone. This does not count ice cream that would be above the cone. This would be what is it when it's filled to the top and not bulging over, of course. And then what about this cone? Just because I feel like we should always have 2 problems of practice. First one, leaving pi in the answer. The formula is pi times radius, which is 4.5, squared, times height, all over 3. So none of those divide nicely, so I'm just going to go ahead and multiply the numbers together. 4.5 times 4.5 times 7, and I'm going to divide that by 3, and it comes out to 47.25. So that would be 47.25 pi, and it is cubic centimeters. So this would be the volume of this cone. This cone if I asked for it in terms of pi. And then I'm also going to do answer B. What about the decimal? 47.25 times 3.14. Here we go. Times 3.14. And that is 148.4. And that does it, folks. Those are your volumes of cones and pyramids.